Most radio signals can only travel 30 to 40 miles from their source. They have short wavelengths that are unable to travel long distances, like on road trips. You can only listen to a CD for so long. Many wanted a kind of radio that would be able to reach them over long distances and to listen to their favorite music genre wherever they went.
The development of satellite radio took 38 years. Scientists, researchers, and engineers had to figure out exactly how it is to make satellite signals into music, and not to be barred by buildings and other tall structures. We figured that satellite radio would work in a similar way to the Bet app on the iPhone. The ground station satellite would send a signal to the satellite, and the satellite would then beam the repeated signal to a receiver that would somehow unscramble the signal and turn it into music. Okay, we didn't actually put it in those words, but something similar. This is actually how satellite radio works. The programming or data for the music station or channel is beamed to the satellites from ground satellites or radio operators. The satellites then beam or broadcast the signal back to Earth, and the signal is picked up by radio receivers. Then it is received and broadcasted again to repeater stations in urban areas. There are two main satellite radio stations in the United States of America. That is the XM and the Sirius radio stations. XM radio uses two Boeing HS 702 satellites, which are placed in parallel geostationary orbit, which really is just about 22,233 feet above Earth, when usually is used for communication satellites. These two of these satellites are actually at 85 degrees west longitude, and the other two are at 115 degrees west longitude. XM radio's ground station transmits a signal to the two active GEO satellites, which bounce the signals back down to the radio receivers on the ground. The radio receivers are programmed to receive and unscramble the digital data signal. Sirius radio station works in a way similar to the XM radio station. The only difference is that the Sirius satellites hover above the equator and their orbit is elliptical. Their satellites receive the signals from the receivers and then bounce them back to the radio receivers on the ground. The radio receivers are programmed to receive and unscramble the digital data signal, just the same with the XM. XM and Sirius radio stations are located on the 12.5 frequency in megahertz of the radio spectrum by the U.S. Federal Communications Commission.
Satellite radio works the same way that a satellite TV will work. You pay a certain fee, which is about $12 to $13, for a certain number of channels. The problem that was posed by these satellites was when the signal would blur or be blocked out when tall buildings and objects interfered. Engineers had to figure out how to squeeze many channels into a small amount of bandwidth and come up with reliable methods of beaming signals from outer space to moving antennas smaller than tennis balls. Exim solution to the disturbance in the satellite signals was a network of repeaters, antennas on buildings and other sites that receive satellite signals from the strategically placed antennas and retransmit them. A less-known key to satellite radio is visual compression, a technique used to use radio spectrum as efficiently as possible. Most satellite radio broadcasters use this high-end technology to squeeze as much material as